Alright, question 1. Use the information diagram and proof to fill in the blanks. Given triangle ABC, prove that the sine of A divided by little a is equal to the sine of B divided by little b. Segment CD is drawn perpendicular to segment AB, therefore H is the height of triangle ABC. In triangle CDA, blank is equal to H over B, and in triangle CBD, blank is equal to H over little a by the definition of blank. Therefore, the sine of A divided by the sine of B is equal to H divided by B divided by H divided by A, which equals H divided by B multiplied by A divided by H, which equals A divided by B, which can be rewritten as sine of A divided by A equaling the sine of B divided by the little b by the multiplication property of equality. Match each letter X, Y, and Z with the word or phrase that correctly fills in the corresponding blank in the proof. Okay, so let's just start with the triangles they're giving us. Triangle CDA. Alright, triangle C to D to A. It is saying blank is equal to H divided by B, and when I read this, there was a context clue that I noticed. I also noticed that H divided by B showed up right there, and in the equality, it's equal to sine of A. So there is my clue right there using context clues that in this triangle, CDA, I'm going to be looking specifically at angle A to find this ratio of H divided by B. So if I label this triangle according to the perspective of angle A, the side opposite it, which is side length H, is the opposite side, and the side length opposite the 90 degree. Remember, if this is marked 90 degrees, this is 90 degrees as well. It's from the very beginning of this course. It's one of the right angle theorems. So this is the hypotenuse. And again, using that context clue from here to here, sine of our angle, sine of angle A, would equal the opposite side length, which would be H, divided by the hypotenuse, which would be little b. So it is sine of A. So X is our sine of A. And then it says in triangle CDB, we have blank is equal to H divided by A. So I kind of, again using context clues, right here, I see H divided by A in the denominator right there, and I also see in its equality that it's equal to sine of B in the denominator. So if I label this, I'm just going to verify it. According to angle B, the side opposite it is H, which is our opposite side length, and the hypotenuse is opposite the 90 degree angle, which is little a. So if we were to write it out, sine of angle B really does equal the opposite side length, which is H, divided by the hypotenuse, which is little a. So the blank Y is sine of B. Again, I used context clues and then I verified it. So we have sine of B by definition of, well, I'm using sine, so it's going to be by definition of our sine. And that's what we would fill in the blanks for X, Y, and Z.